So today we're going over chapter 1, section 3, solving equations. So verbal expressions can be translated into algebraic expressions by using the language of algebra. So addition, you can also be called plus, the sum of, increased by, total, more than, added to. And for subtraction, you have minus, a difference of, decreased by, fewer than, less than, subtracted from. You have multiplication, which is times the product of multiplied by of each. Those are all words for multiplication. Then we have division, divided by or the quotient of. The last one you usually see is per. This is the most common words that you will find for, in word problems, so you to write equations. On this third slide, they want us to write the algebraic expression to represent each variable or each expression. So number 1 is the difference of a number p and 36. Because they're saying the difference, you would write it as p minus 36. If you guys remember from last year. If it were a different type of wording, then you would flip it. Something like would be less than another number, so you would kind of flip them. But for this part, this first one, the difference would be right in the same order. So for number 2, it says 15 more than number q. Because it's more than, it means it's a addition. So we would just write 15 plus q. Now, in addition, the order doesn't really matter. Subtraction, it does matter because that will change the sign of the second number. So keep in mind, for addition, you guys could have put q plus 15 or 15 plus q and it would still be correct. The product of 10 and a number r, product falls in multiplication. So we have the product of 10 and r. You could write it as 10r. Also, you can write it as 10 times r. You can write it as 10 parentheses r. Any type of different thing, you can write it. Those are all products. You could have even written it as r times 10. For multiplication, the order doesn't matter either way. I would just rather go in order of what is written when I can, to make it more consistent, and that way you make less mistakes as time goes on. We have the total of a number y and 9. Total is the fourth one on the previous slide for addition. So it would be y plus n. Again, I'm just going in order from left to right to make it easier and to be consistent with my work. If you wrote 9 plus y, that is fine. You're not going to have any problems with it. For number 5, we have 2 more than 4 times the cube of a number. Remember, when this says a number, it's just a variable. I will most likely always choose x to make my life easier. So a number is just a variable. I'm just going to choose x whenever I can. So there's 2 more than, and then 4 times the cube of a number. So it'll be 4x cubed, right? And then it says 2 more, because it's 2 more, we'll add that to what the multiplication is. So it'll be 4x cubed plus 2. And for number 6, we have the quotient of 5 less than the number and 12. Again, a number just means a variable. So the quotient of 5 less than a number and 12, that means the quotient is x over 12. And then it is minus 5. Even though this one is not written the way we wrote it down on the equation, this would be the way it would work. I'm going to write it up here for the recording, just in case it gets cut off. The reason I wrote it with the x minus 12 first is because they're asking for the quotient and they're asking for it to do 5 less. So they're subtracting 5 from whatever the division is. So for it, we have 6x equals 72. So I can say 6 times x equals 72. You could have also said 6 times a variable equals 72, or the product of 6 and x equals 72. Those are just different examples. You could also have something different, but I'm just saying them out loud so you guys can have them. The second one, I'm going to write again, just the first one that came to mind. N plus 15 equals 91. You could also say the sum of n and 15 equals 91. N increased by 15 equals 91. The total of n and 15 equals 91. 15 more than a number equals 91. So there's multiple ways you can write it, or you can add or say it. Again, I'm just writing one way and saying multiple so you guys have the options. Here we have the properties of equality, which is to solve equations we can use properties of equality. Some of these properties are listed below. You have the reflexive property, the symmetric property, the transitive property, and the substitution property. The reflexive property, it just means that a number is equal to itself. So here we have example A equals to A. We also have in the examples B plus 12 is equal to B plus 12. That is always true because B would be the same number and 12 and 12 are always equal. Then we have the symmetric property, which states for all real numbers A and B, if A equals B, then B equals A. What does this mean? If you have the expression 18 equals negative 2n plus 4, you can write it as negative 2n plus 4 equals 18, and it's the same. It just means that we flip the order of the equation, but at the end of the day, it's going to equal the same because they are the same numbers. You have the transitive property, which states for all real numbers A, B, and C, if A equals B, B equals C, then A equals C. This means that if 5p plus 3 equals 48 and 48 equals 7p minus 15, then you have 5p plus 3 equals 7p minus 15. Now this is the hardest one to understand based on what I've seen from previous years. So if it is, for example, if p equals A, right? And then we have A equals B, we can get rid of this middle one, kind of sandwich, and we could just go ahead and say that P equals B straight off the bat. Now this is a lot simpler as there are only one letters, but the same thing applies with the equation. In our example here, we have 5p plus 3 equals to 48. And then they say again 48 is equal to 7p minus 15. Notice how the 48 is sandwiched in between those two expressions. And because it is kind of in the same idea, you can kind of ignore the middle because they are exactly the same. And then just equal, in this case, the red with the red. And then lastly, we have the substitution. That saying is if A equals B, then A may be replaced by B and B may be replaced by A. We did this last year when we were solving by substitution. They will give you an equation, let's say y is equal to 2, and then you had an equation that was 2x plus y equals 5. You would plug that 2 into there, and you would do, well, 2x plus 2 equals 5. That would be a substitution, and then you solve it. That would be the substitution property. It is the same if you would have been given the x, you're able to solve it. Just make sure that you're plugging into the correct variable. So we have solving equations. The goal is solving an equation to get the variable by itself on one side of the equation and a number on the other side of the equation. This is what I've been saying since last year. Your goal when you're solving an equation is always to get the variable by yourself or by itself. So to isolate the variable, we must reverse the operation acting on the variable. We do this by performing the inverse of each operation on both sides of the equation. This is what we've been doing. If you have an addition, you subtract. If you have subtraction, you add. If you have multiplication, you divide. And if you have division, you multiply. You always use the inverse operation. So in order to follow this, we have x plus 13 equals to 7. So we're going to subtract the 13 on both sides. When we subtract the 13 on both sides, it cancels out that 13 on the left side and moves it to the right. Remember, you can do whatever you want to an equation as long as you do it to both sides. So in this case, I'm just subtracting. Again, the goal is to leave the variable alone. So when I do that, I get x is equal to negative 6. Now, for the second one, we have negative 6x is equal to 42. Now, we have a multiplication, so we use the inverse operation, which is a division. So we go ahead and divide by negative 6 on both sides. And when we do that, we get that x is equal to negative 7. Alright, so in this problem, they want us to solve for y. Remember the key concepts. You gotta simplify each side of the equation if needed by distributing or combining like terms. That is always the first step that you should be looking for. How can I make it easier? Now the second point states, move variables to one side of the equation by using the opposite operation of addition or subtraction. The third step would be to isolate the variable by applying the opposite operation each side. So that means if you have an addition or subtraction, you do the opposite. And if you have multiplication or division, you do the opposite. Now again, when you're solving this type of equations, you want to make sure that you start with addition or subtraction first, and you multiply and divide last. And then lastly, you can check your answer by plugging it in. So the problem we have is negative 6y minus 8 equals to 16. Following these problems, we cannot simplify anymore, as we have one term with the variable and one term without the variable on each side of the equation. The only thing we can do is move the variable to one side or the other. In this case, we already have it on the left, so let's just keep it on the left. For us to be able to isolate that variable, we're going to add that 8 on both sides. And when I do that, that cancels the 8 on the left side. So this becomes negative 6y equals to 24. Then when I divide by negative 6 on both sides, I end up with y is equal to negative 4. The last step will be to check. How do you check? Well, you plug that into the original equation. So it would be negative 6 times negative 4 minus 8 equals to 16. We have 24 minus 8 equals to 16, and 24 minus 8 is 16, so 16 equals to 16. Therefore, we know we got the right answer because when we check it, we get the same number on both sides. Now, if you don't have time, you don't have to check, but it is recommended in order for you guys to get the right answer, or make sure you have the right answer. We have to simplify, move, isolate, and check your work. The first thing you want to do is simplify. How do you simplify? You have to distribute that 5 into both of those terms. You get 3 plus 25n plus 30. Then that will equal to 33. I will then go ahead and combine the 3 and the 30 on the left side, because that is simplifying, that is still combining like terms. So that becomes 25n plus 33 equals to 33. I will then go ahead and subtract 33 from both sides. The reason I'm subtracting 33 is because the 25n is the variable that we want to make sure is alone. So we get 25n equals to 200. I will divide 25 on both sides. N equals 8. Now, how do you know if that's right? If you're confident with your work, you go ahead and just leave it. I always recommend checking your work. So it would be 3 plus 5, 5 times 8 plus 6 equals to 33. Now, remember, pandas, you start with the stuff in the parentheses. So it would be 8 times 5. So that would be 3 plus 5, 40 plus 6 equals to 33. That becomes 3 plus 5 times 46 equals to 33. 46 times 5, it is 230. So we have 3 plus 230 equals 233. And 230 plus 3 is 233. With that equals 233. Therefore, while you checked your work, it was able to be solved. And you know it's correct because it equaled the same thing on both sides.